This video is brought to you by mywayteaching.com.
Adiabatic process. See, in this adiabatic process, the system is insulated from the surroundings and heat absorbed or heat released is zero, which means no heat flow takes place between the system and the surrounding. So we see that work done by the gas results in decrease in its internal energy. So for an ideal gas, we can write PV gamma is equal to constant. So where gamma is the ratio of specific heats at constant pressure and at constant volume. Okay, ratio of specific heats at constant pressure and even at constant volume. Thus, if an ideal gas undergoes a change in its state adiabatically, P1 V1 to P2 V2, then we get an equation P1 V1 gamma is equal to P2 V2 gamma. So you can see in this particular figure PV curves of an ideal gas for two adiabatic processes connecting two isotherms. Okay, two adiabatic processes connecting through isotherms. So we can calculate as before the work done in an adiabatic change of an ideal gas. Work done in an adiabatic change where no heat flows between the system and surrounding and it is insulated from the surrounding. That is given by okay change in state, that is P1 V1 T1 to the state P2 V2 and T2. So that work done is given by integration over the limits okay V2 V1 PdV. So substituting, isn't it? If you integrate this, we get minus gamma plus 1 by 1 minus gamma from okay V2 V1. That is also equal to constant we get, can take 1 minus gamma outside, and if you substitute the values, first is V2, then is V1, okay, and the constant P1 V1 gamma or P2 V2 gamma. We get W is equal to 1 minus gamma P2 V2 gamma V2 gamma minus 1 P1 V1 gamma V1 raised to gamma minus 1. That is 1 minus gamma, which is given by P2 V2 minus P1 V1, isn't it? We can write it as mu r T1 minus T2 by gamma minus 1. So if work done by the gas in an adiabatic process, that is W greater than 0, from the equation, that is mu, this equation 1, we can say in that T2 is less than T1. On the other hand, if work done on the gas, this is work done by the gas, okay. Here work done on the gas. W is less than 0 and T2 greater than T1. The temperature of the gas rises. So this is the description about adiabatic process. Okay. So the equation is given by the 1. Now let us study what is this isobaric process. See, we already know in an isobaric process, volume is constant, isn't it? Yes. No work is done on or by the gas. The heat absorbed by the gas goes entirely to change its internal energy and even to change its temperature. Okay, it is utilized to change its internal energy and even to change its temperature. The change in temperature for a given amount of heat is determined by the specific heat of the gas at constant volume. So, this is used to determine the change in temperature for a given amount of heat. Okay. Now let us see what is isobaric process. See, in an isobaric process, P is fixed, which means pressure is constant. Work done by the gas is given by W is equal to P V2 minus V1. We can also write it as mu R T2 minus T1. Since temperature changes, so does internal energy. In this case, the heat absorbed goes partly to increase the internal energy. Okay, heat absorbed, it is utilized in for two causes. One is to increase the internal energy, and the other one is partly to do work. So the change in temperature for a given amount of heat is determined by the specific heat of the gas at constant pressure. Okay, that change in temperature, we measure it by the specific heat of gas at constant pressure. Now let us study one more important process, that is cyclic process. So in this particular process, the system returns to its initial state. Since internal energy is a state variable, we can say the internal energy for a cyclic process is zero. The total heat absorbed equals the work done by the system.